Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Mr. Joseph or Mr. Explicit. Please, as you are watching this video, endeavor to subscribe, like, share, and comment so that when I upload a new content, you'll be notified by YouTube. Alright, in today's video, we shall be looking at one of the striking or interesting topics in the world of physics, and that happens to be reflection at plane and curved surface. We have two types of mirrors, the plane mirrors and curved mirrors. The question is, what is a mirror? A mirror is a smooth reflecting surface that is coated or polished with a metallic substance. Alright, mirrors can be defined as smooth reflecting surfaces that are coated with a metallic substance such as silver, tin, and what? Mercury. These three elements are the most commonly known elements or metallic elements that can be used to coat mirrors. I take it again. Mirrors can be defined as smooth reflecting surface that are coated with what? Metallic substances such as tin, silver, and what? Mercury. That is for that. On a broad note, we have two types of mirrors. We have the plane mirrors and we have the curved mirrors. Curved mirrors. As the name implies, plane. Plane mirrors are mirrors that have flat, smooth, reflecting surfaces. Alright, plane mirrors are mirrors that have flat, smooth, reflecting what? Surfaces. Alright, so let's now discuss or let's look at how image is formed by a plane mirror. Let's give it a try. Let's try it if we can actually have, if I have here as, if I should have here as point G, all right, and I have here as point H. Okay, I have here as point H, and I have the middle to be Q. I have the middle to be Q. Of course, it's coated. And somewhere here I have an object. So what happens? Let's consider a ray of light coming from this region. I'll just do it like this. This point, I can make it, I can use any alphabet. Let me use M. So a ray of light is coming from point O, all right, and it forms an angle of normal and now have angle of what? Reflection. As soon as this ray gets incidented on the surface, it forms angle of what? Incidence. All right, angle of what? Incidence. And this one that gets reflected, as soon as this one hits the surface, use an arrow to denote it. This the normal. This is angle of what? Reflection. You use an arrow to denote it. So I'll say OA is what? The ray of light, which is the incident ray. All right, then I'll use WP. WP is what? The reflected ray. The reflected what? Ray. All right. OM is the angle of incident. The incident ray, while WP is what? The reflected ray. And of course, the angle to the that is angle of normal is formed between the reflected ray and the incident what? Ray. Another note, if oh god, I refilled these markers just now. So if I have an incident ray coming this way, don't forget, it's very important to use your arrow. It reflects, it forms normal. So here is N, of course. Let me make this place as S and F. Sure. Do you know that this is what the angle of incidence? This is angle of what? This angle of incidence, right? The angle of what? Reflection. So this R1, I1, U. If I should divide this, what will I have here? I'll have I1 R2, all right? And this one I can just, this I'll use I2 R2, because we are referring to different incidences and different what reflections, so we have to use alphabets that will make us not to get confused during the long run, all right? So from what we've done so far, we are considering just 2 points, right? Point OM and point what? SF. Here is the angle of incidence, and here is what? Angle of what? Angle of reflection. God of Nazareth. Angle of reflection. So I'll use a broken line to denote, to express something here. I feel this mark. God now. So I have, if I should extend this with a broken line, all right. So I have this. Don't forget. So this place is angle of what? Reflection, right? So this arrow, is that not correct? This angle of reflection, angle of what? Reflection, that is up. I can do it like this. Angle of reflection. Then at this point that is just opposite this object, this is where the image is formed. So I'll use image is what? Formed. I'll use what? I. So I'll also use arrow here. Normally you have arrow, and you have what? Arrow. Alright, so you also have this I and this arrow. So our major focus right now is the point where the rays of light are coming from and the point where the image is formed. Please, at point I, this very region, this is where the image is formed by the plane mirror. Alright, this is where the image is formed by this plane mirror. Alright, you also agree with me that based on the law of reflection, which states that the angle of incidence is equals what? Angle of what? Reflection, and they are to the what? The normal. Angle of incidence to the normal is equals what? The angle of what? Reflection. Alright, so please, now somebody standing that is at the front of this reflected ray would think it is coming from the behind. So that's the image that is formed from behind is called what? It's called virtual image. Virtual image. Virtual image. Virtual image. And please take, we have virtual image and we have real image. Real image is formed by a spherical mirror. Real image is formed by a spherical mirror. Now, if I may ask, what are the differences between real image and what? Virtual image. What are the differences between real image and virtual image? One, real image permits the passage of light through it. Real image permits the passage of light through it, but virtual image does not. Does not actually permit the passage of light through it. Secondly, real image is the one formed on the movie screen. So which means that real image can be formed on the movie screen, while the virtual image cannot be formed on the movie screen. So these are the two differences between real image and virtual image. So please take note of what I've just done. This is where the image is formed, and here is the angle of reflection. This is the angle of incidence, and of course you have the same thing here. So please, we are done with this. Take note of this. Take note of this. Take note of this. Now let's look at the characteristics of the images formed by a plane mirror. Now, what are the characteristics of images formed by a plane mirror? Definitely one, that is object distance, which is noted as what? U, all right, is equals to, all right, image distance. The image distance is denoted as what? V. The object distance is equals the image distance. Number two, the image formed, I told you, is virtual. The image formed is virtual. And three, the image is erect or upright. The image formed is erect or what? Upright. And the image formed by a plane mirror is also unmagnified. Alright, I'll say it is what? If I don't use the word unmagnified, I'll say the image is what? A diminished image. Alright, so number 5, the image formed by a plane mirror is laterally inverted. Laterally what? Inverted. Laterally inverted, and the image formed are to the infinite or infinite. All right, please take note of these are the features of the images formed by a plane mirror. The object distance, which is u, is equals to the image distance v. The image is virtual, it is erect or upright, it is unmagnified, or you say it is what? Diminished. It is laterally what? Inverted. What that means is sometimes you look at yourself on the mirror, you would observe that your right hand becomes your left hand and your left hand becomes your right hand. That is what we mean by what? Laterally inverted. Your left hand becomes your right hand and your right hand becomes what? Your left hand. So that is that. So these are the features of the image formed by a plane mirror. They ask you, which of the following is not true about the image formed by a plane mirror? Please take note of everything that has been said so far. Please take note of this. Now, what are now the two types of plane mirrors? What are the two types of plane mirrors? We have the concave or converging mirror. We have concave or converging mirror. So we have the convex or diverging mirror. So these are the two types of mirrors that we have: concave mirror and convex mirror. Please take note that the concave mirror is coated inside. The inside surface of the mirror is what? Coated. That is what? Concave mirror. But as for the convex mirror, the what's it called now? The outer surface of the mirror is coated, but concave is inside, the convex is what? Excuse me. So convex mirror is outside, is coated outside, but concave mirror is coated inside. So please take note of that. Don't worry, as time goes on, I'm going to be explaining the different terms associated with what? Curved mirrors, such as vertex, principal axis, or principal that is principal axis, principal focus, or focus point. You have radius of curvature, center of what? Curvature. So as time goes on, we are going to be explaining all this. All right, so I'll rub off what I've done, what I've written. So the next one is, let's take how do I put it now? Okay, different terms associated with curved mirrors. Different terms associated with curved mirrors. You have one, the vertex. If I have a surface such as this, let me use a convex mirror. The middle of this mirror, that is, the middle surface of this mirror is called what? Vertex. Vertex. Alright, I'll draw a line. This point, I'll consider it as my principal focus. This point I'll call my principal focus, and this point I'll call center of what? Curvature. Center of what? Curvature. Now the line that joins center of curvature, principal focus, to the vertex of this mirror is called what? The principal axis. I take it again. The imaginary line that joins radius of curvature and the principal focus to the vertex of the mirror is called what? The principal axis. It's called what? The principal axis. That is center of curvature. That is, let me write it. Curvature rather. Center of curvature. That is C. This one is written as what? Okay, now V. The center of curvature of a mirror is that point that allows light ray to pass through it. It is that point that allows ray to pass through it, thereby forming a section. All right, number four. Number four term is radius of curvature or curvature. Radius of curvature is the distance between the center of curvature, all right, to the it is distance between the radius of curvature and the vertex. The distance from this radius of curvature to the vertex, this distance is called radius of what? Curvature. Radius of curvature. All right. So now, as time goes on, I'm going to be explaining. See, this one from here to F, from this place to this place, all right, is one radius. From here to here is another what? Radius. Don't worry. As time goes on, or I can just use. I have F. I have what? F. All right. So number 6. We also have what is called the focal length. The focal what? Length. If I have, how do I put it now? If I have, let me illustrate something. Let me denote here as my curvature, point curvature. Now this ray of light, they will let me, all right. Now this region where light rays converge, the meeting point or the point where diverging and converging light rays meet is called what? This point is called the principal focus. That's number 5 now. Principal focus. And it's denoted as what? F. Now this region where that is this region where this, you see, this ray is coming from a very large source, and they meet here. This one is coming from a large source, they meet here. So this region where these light rays converge, where they meet to converge, is called what? The principal focus, and it's known as what? Capital letter F. The principal focus. While the distance between the principal focus and the radius of curvature, that is distance between the principal focus and radius of curvature, is called what? The focal length. Small letter what? F. I take it again. The region where rays meet, in order for them to converge or to meet, is called what? The principal focus. All right. While distance between the radius, the center of curvature, to the principal focus is called what? The focal length. Please take note of that. It is very, very important. So these are the various terms associated with curved mirror. Vertex, I've explained what vertex is, the middle surface of the mirror. Principal focus, principal axis, I said, is that line that joins the center of curvature and the principal focus to the vertex. All right. You now have center of curvature. I said it is that point that allows the passage of light through it, thereby forming different sections. And I said radius of curvature means the distance between the center of curvature to the vertex, just as illustrated here. And of course, it's noted as what? Big letter arrow, big letter arrow, big letter arrow. You now have focal length, which is the distance between the center of curvature to the principal focus. Small letter what? F. I then said that the region where light rays meet to converge is called what? The principal focus. So these are the different terms associated with curved mirror. I believe it's clear enough, all right, isn't it? So let us look at the relationship between radius of curvature and focal length. Relationship between radius of curvature and what? Focal length, which is what? F. Now, if I have a surface such as this, all right, I have an incident ray, all right. Of course, don't forget your principal axis. You know this is the principal axis, right? Now, you agree with me that as soon as this incident ray touches the surface of this mirror, all right, what do you think will happen? It will reflect. All right, so this region is called let me draw it again, please. Okay. As soon as it touches the surface of this mirror, it will what? Reflect. All right. So you now have here this point. Of course, you have the normal, right? This is the angle of incidence, like angle of incidence. Hope is clear there. It's somehow tiny here. Then here is what? Reflected ray. And this is what? The incident what? Ray. Now this region is called what? Curvature. Alright, curvature. And this region you have what? The principal focus. Now, before I start deducing formula from what I have here, now the region, of course, this is a vertex, right? The region where this reflected ray caught this line, you know, is a principal axis, right? This line is called the principal axis. All right. The region where this reflected ray caught the principal axis is called what? The principal focus. You can see this very one. It is a normal that is crossing this. All right, which is the center of curvature. I'm referring to this reflected ray. So the region where this reflected ray cuts the principal axis is called what? Principal focus. That is big letter F. So let me make here M. All right. Okay. From what I have now, I can say CF. All right. CF is equals MF and is equals what? VF. That is CV. Oh my God. CF is equals to what? MF and is equals to what? VF. That is what you have it to be. Now, from what we've written, see, CF is also called what? It's also VF. Or if I don't want to do it like this, I'll say already you have your VF here. If VF is also if CF, all right, is also VF, it means that we'll have another VF and it's equals to what? Radius. I'll take it. You have CF equals MF equals VF. If these three are equal to each other, already I have one CF here. I have one VF first and first. If VF or if CF is also equals VF, so which means that wherever I see CF, I'll put VF. So that's what I have here. So here I have from this region to this region is called one focal length, just as I deduced before. This region to this region is another focal length. All right. So which means that I'll have F, and here I'll have F. I'll have what? Arrow. Hope is clear enough. Just take it bit by bit. Don't forget, I said from here to here I have one F. Then from here to this place I have another what? F. So I have this plus this. You have what? F plus what? F. All right. Now F plus F is what? 2F, and is equals what? Arrow. So let me use big letter arrow for a better understanding, because I told you guys that the distance from the center of curvature to the vertex is called what? Radius of curvature. Big letter what? Arrow. So I have arrow. So from what I have here, I will divide both sides by 2. So focal length is equals what? Arrow over what? 2. Now, from what we've written, it means that the radius of curvature, is twice the focal length. If I should cross multiply, I'll be having arrow is equals what? 2F. The radius of curvature is twice that of the focal length. All right. Don't forget the region where this reflected ray cuts the principal axis is called what? The principal focus. From here to here you have your F. From here to here you have your what? F. So the distance between here, there is distance between this and this is called what? Big letter arrow, and which is what? The principal, which is radius of curvature. So from what I've done, if you should do it, you definitely have radius of curvature to be twice that of the focal length. So please take note of that. It is very, very easy, all right? It is very, very easy. So don't forget this formula. Don't forget it. Now let us now discuss the types of rays. The types of rays. Types of rays. We have the parallel rays. Now let me consider a surface. If I have a surface such as this, if I have this, and I have this, now this is the incident ray, right? If I have another here, this is another incident ray. Don't forget the arrow. The arrow is very important. A type of ray that is incidented on the surface of this mirror, and is parallel to the principal axis. You know this idiot. This very guy is the principal axis. Alright. Then I told you that the region where this you need to reflect. I use arrow. This region where this reflected ray cuts this principal axis, of course, is what is the principal focus. So, which means that a parallel ray is that type of ray that is parallel. Notice these two lines are parallel, right? So, of course, this one will also reflect. So these two rays, this line is not straight. It's like it's suffering from epilepsy. Oh, Jesus Christ of Nazareth. Please do it better for yourself. Alright, here I have. God, forgive my diagram. So what I have here is these two lines. Alright, these two lines are parallel. This line and this line, they are parallel to each other, right? And it means that they are parallel to the principal focus. And these two reflected ray, to cut the principal axis. Alright, I told you guys that the region where, or the point where this reflected ray cuts the principal axis is called what? The principal focus. Alright, the principal focus. So what I've just drawn is the parallel rays. The next one is called the chief ray or radical ray. The chief ray or the radical ray. If I have a surface such as this, the ray that passes through the radius of curvature, don't forget an object is here. There is the ray that passes through the radius that is the center of curvature. The center of curvature is actually called what? The chief ray or radical ray. The chief ray or radical what? Ray. However, as for the third one, which is the focal ray. Good. These markers, I refill them. I don't know why they are stressing me. So if I have this, I draw this. So the ray that passes through F, is called what? Focal ray. That passes through this F is called what? The focal ray. So these are the three types of rays that we have. So from what we have done so far, I've given you what concave mirror is, what convex mirror is, what whatever is. So let us now look at some instances. Okay, let me introduce you magnification. Magnification can be defined as a ratio of image distance. Don't forget this minus here connotes what? Sign of convention. Magnification is a ratio of what? Is a ratio of the image distance to what? The object distance. It is a ratio of the image distance to the object distance. Don't forget, big letter M, which is magnification, is equals minus V over what? U. This is what? Magnification. Then of course we have the mirror formula, right? We have the mirror formula, and the formula is actually 1 over f is equals 1 over u plus 1 over what? V. For easier work, if you are looking for the focal length, simply do it as f is equals uv over u minus what? Okay, u plus what? V. If you are asked to look for f, which is the focal length, and this is the object distance, and this is the image distance, of course. If you are asked to look for the focal length, you just use uv over u plus what? V. However, if you are looking for v, if you are asked to look for v, which is the image distance, you are going to be using uf over u minus what? F, equation 2. Equation what? 2. Of course, if it's simple now, it's simple. To get this, I don't know if I should do it for you guys. Okay, let me just do it. 1 over f is equals, the LCM of u and v is uv. U into u, I'm left with what? V. So v times 1 is what? V plus v into v, I'm left with what? U. U times 1 is what? U. So I have that. If I should cross multiply here, I'll be having uv is equals, that is, uv is equals, I'll use this f to open a bracket, alright? If I should do that, I'll be having f u, okay, no, don't do that. So I have 1 times uv is what? Uv. So I'll use this f to open the brackets here. I almost made a mistake. So f times v is fv plus f times u is what? Fu. Is fu. Don't forget I have my uv. F is common, so I'll factorize, bring out one f. Then you have u plus what? V. U plus what? V. If I want to make f the subject of the formula, I'll divide both sides by u plus v. U plus what? V. So this will go into this. You have f equals uv over u plus v. That's what I have here. Alright, so it is very, very simple. Alright, same thing is also applicable if you want to make v the subject formula. Alright, this okay, don't forget this, oh God of Nazareth. If you want to make v the subject of the formula, don't forget I have that uv is equals fv plus what? Fu. Alright, since we are making v the subject of the formula, you take to one side all the v's. So which means that uv minus is coming over fv is equals what? Fu. uv, this one come over becomes uv minus what? Fv equals what? Fu. So what do I do next? If I want to make my v the subject of the formula, what do? I'll factorize. I have v. So I'll bring v, open brackets, I'll have v u minus f. I have my what? Fu. So if I divide both sides by v, I'll have u minus f, u minus f. So that is what I have here. So this is for equation 2. I just did for those of you who may be confused how I got it. I believe it's well explained now. So that is for, in case if you are asked to look for f, just use this simple formula, this very one. Then if you are asked to look for v, you use uf over u minus what? V. Take note of that. This is the mirror formula, and this is formula for what? Magnification. Now please take note of what I'm about to say. Take note of what I am about to say. Take note of what I am about to say. Number 1, the absolute value of m is greater than 1. The absolute value of m is greater than 1 when the image is enlarged or magnified. I'll say it again. The absolute of m is, when it's greater than 1, it means that the image is what? Enlarged. When the absolute value of magnification is greater than 1, it means that the image is what? Enlarged or magnified. But when it is less than 1, it means that the image is reduced or diminished. Alright, it means that the image is what? Reduced. And when the absolute value of m is equals 1, alright, it means that the image is true or real. It means that the image is true or what? Real. Please, in a concave mirror, please, radius of curvature and focal length are positive. The radius of curvature and focal length of a concave mirror are positive, please. But in a convex mirror, please take note that the radius of curvature is negative and the focal length is also what? Negative. Take note of this also. The image, when an image is formed at the front of the mirror, alright, when an image is formed at the front of the mirror, such image is positive. The image distance is usually what? Positive. When it's formed at the front of the mirror, but when the image is formed behind the mirror, it is what? Negative. When the image formed is at the front of the mirror, V is positive, but when it's formed behind the mirror, V is what? Negative. Take note that real image, oh God of Nazareth. Take note that real image is positive. However, the virtual image is what? Negative. The virtual image is what? Negative. The virtual image is negative and the real image is what? Positive. When the image is formed behind the mirror, it is negative, and when it's formed at the front of the mirror, it is positive. The radius of curvature and focal length of a convex mirror is negative, while that of a convex mirror, it is what? The both of them are positive. But when the absolute value of m is equals 1, it means the image is real or true. But when it's less than 1, it means it's reduced or diminished. But when it's greater than 1, it means it's what? Enlarged. So please take note of that. It is very, very important. So please always note that the image formed by a convex mirror are usually vague. Convex mirror form what is called what? Vague. Vague. V stands for virtual, erect, and what? Diminished. If I don't use the word erect, I'll use what? Upright. Please take note that the image formed by a convex mirror are virtual, erect, and what? Diminished. So vague is to convex mirror. However, a concave mirror has the ability to form, different images based on the position of what? The object. Alright, the object, when positioned differently, you have different images being formed. Alright, it's not on this topic. What I'm about to do right now is not on this topic, but I want to tell us how images are formed by a concave mirror. Now, look at it. When an object, oh God of Nazareth, I refill these 3 markers. Oh God, English people. Hope it's recording, excuse me. Yeah, it's recording. The marker is just stressing me. Please, when an object is found between the focal length and, okay, you have, how do I put it now? When it's found between the focal length and lens, when an object is found between the focal length and lens, this is what will happen. If I have this, let me assume this region to be where the lens is. There's a lens, and this F, that is F1, and I have another what? F1. If the image is found between focal length and what? Lens. This is a lens, right? And this is a focal length. Of course, this is what is going to happen. You have this. Now, if I should, you also have something like this. If I should extend this, oh God, this. There's a point it will get to, they'll meet. All right, so you see that. Can you see what I've done now? So this region, you see, this is the objects. Don't forget the object was placed between F and lens. All right, look at what is going to happen. The image, this is the object, the image has formed behind F. So which means that every image that is placed, or every object that is placed between F and lens, you have them to be magnified. That is larger than the object. You see, it is larger than the object, larger than the object. What do you think? It is virtual, right? It is virtual, erect, or upright. It is erect or upright. Then where is the image formed? It is formed behind the object. Formed behind the object. You see that? Can you see that right now? So when an object is placed between focal length and lens, all right, you have the image being formed behind it. The image is formed behind it, and the image is erect or upright, and it's virtual, and it's very big. It's larger than the object itself. Please take note that when an object is placed between F and lens, these are the images, or these are the features of the image that has been formed. All right. Please, that is for that. If an object is placed at F, if I have F1 here, and I have my lens, and I have another F1, the image that when an object is at F, you have this. It ought to cut through this radius of curvature here. Radius of curvature, right? Don't forget, this region is called what? Radius of curvature. You see now that the image is infinite. The image is infinite. Now, please take note of this. Let me say this. I told you that when an object is placed between F and lens, you have a very large image. It's erect or upright. It is virtual, and the image is formed behind the object. Please, the word there is virtual. Please, apart from that illustration, all other images formed by a concave mirror, it is always real magnified, real magnified. Only sometimes you only see them to be smaller than the object. So please, when an object is placed at f, when an object is placed at f, the image is real. That is real. And what? Infinite. It is real and what? Infinite. Real and infinite is just going, you see. So please take note of that. It is very, very important. Now, another one. When an object is placed, okay, if I have 2f, I have f, I have my length somewhere here, which is, I have radius of curvature, and I have f, and I have 2f. You must calculate the distance. You must take your measurement such that from here to here is also equals from here to here. From here to here should also be equals to from here to here. That's how it is. An object that is placed between 2f and f. An object that is placed between 2f and f, I have this. Oh God. If I have, oh, there's no space. If I should extend this, if I should extend it somewhere here, this region where they intersect, you see that the objects, sorry, I'm tampering with the questions here, but just no problem. So, you see, when an object is found between 2f and f, alright, what will you observe? You observe that 1, the image is definitely real, or 2, okay, inverted, that is, it's inverted, right? It's inverted, upside down. 3, what will you observe? It is larger than the object itself. Look at it now. It is larger. You can say, okay, let me just use magnified. Magnified or larger than the object. Larger than the objects. Larger than the objects. Larger than the what? Objects. Where is the image formed? It is formed beyond 2f. Alright, it is formed beyond 2f. Please take note of this. It is very, very important. You know, sometimes it's not about cramming. You should be able to illustrate what you are saying. Alright, it is very, very important. Alright, so please, when an object is placed between 2f and f, it is real, it is inverted, upside down, magnified, that is larger than the object itself, and image is formed beyond f, beyond 2f. Alright, it is formed beyond 2f. Please take note of that. Okay, if I also have okay, if this object is placed beyond 2f, if this object is placed beyond 2f, all right, of course this one will be a bit confusing because this stuff is too long. Okay, let me reduce it please. Because of this, I have f1, I have 2f, I have f1. Please take the measurement to have an accurate image beyond f. So I have that Okay, this will definitely cut through the radius of curvature, right? Then this one, don't forget. Then this one will also cut through this region. Okay, so if not for the fact that it is not, the measurement is not equal, the image is formed, where? Before 2f. So you say 1, the image is definitely real, is inverted, that's upside down. Let me draw this again, please. It's correct, but I have to have an accurate, because this one is going down. I believe it's okay. Aha. So it's clearer now. Good, 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 good. You know, I'm not using a rule. So what will you observe? The image is real, inverted, upside down. Number 3, smaller than the object. Smaller than the object. Yes, now it's here now. It's small past the object now, all right? And it is number 4. It is where is it formed? Before 2f. It is formed before 2f. So please, you can do others for yourself. When an object is placed between lens and f, the image are actually very large. It is formed beyond the object. It is virtual, and okay, you have behind the object. Okay, virtual, erect. Yeah, it is virtual, erect, or upright. It is formed. The image is okay. The image from beyond f, right? Beyond f, or that is beyond the object. So, the Lord is good. The Lord is good. I have this. Let me do it again. Please, there's no time for that. Just, I've done it already. Just note that there's no space around. I was reset. I want to say it again. The image at 1, the image is larger than the object. 2, the image is formed behind the object. 3, the image is upright. The image is upright or erect. All right. So please take note of that. And the image is magnified or larger than the object itself. So please take note of that. I'll be running up the class. Then in our next class, because of time, we shall be solving these questions and other questions you have on your textbook. But before I do that, let me round off with this. We have different types of lenses. Now, based on concave, we have this. You call this double concave. I have this. You call this a plano concave. And if I now have this, this one they call concave meniscus. Right? We have double concave, we have plano concave, and we have concave meniscus. And you now have, based on convex, you have you call this double convex. You have this plano convex. You have plano convex, and you have this convex convex meniscus. So please take note of that. At this point, we'll call it a day. In our next class, we shall be treating these questions. Please, if you know you learned something in today's video, please endeavor to subscribe, like, share, and comment. Do have a wonderful day.